Welcome, class, to the Intro to Java Programming. Today's lesson on hash maps is the last in a series to introduce 4 of the more popular collection data types. The map is a collection of objects that holds 2 values in the form of a key-value pair. There are several types of maps available, each with their own unique characteristics. We will cover the most popular map, the hash map. The array, array list, and hash set are collections that hold 1 value per element. The hash map is a collection that holds 2 values in the form of a key-value pair. A key-value pair is a set of 2 linked data items with a key being a unique identifier for a data value. Let's talk about the difference between a key and a value. One entry has 2 parts, the key and the value. The key is the index used to access this specific entry. The key is something that easily identifies the entry, like a string or a number. The value contains more complex data about this entry, like a custom object with many properties, or a string value. The idea is to use a simple key to access the desired, more complex value. Imagine you know the jersey number for a player on the team, and you want all the player's data. Data like the player's name, date of birth, university they attended, home city and country, plus much more. The simple key will easily give you more complex data. This is common for getting data on employees and parts. The hash map will consist of many entries and is ideal as a lookup table. Let's say we want to get the name of a country from a country's abbreviation. If we are given the abbreviation JOR, we can use that as a key to get the value which holds the full country name of Jordan. In this example, there are 2 keys that have the same value. We'll go over more examples in the code later. First, let's cover a few simple rules and guidelines to remember. Data is stored in the form of a key-value pair. The size of a hash map can change. The hash map key must be a similar data type object, like all integers, all strings, and even all custom objects like the myBank object from Lesson 4. The hash map value must also be a similar data type object. However, the key and the value do not have to be the same type object. The hash map will not maintain the order key-value pairs are added. Duplicate keys are not allowed. Duplicate values are allowed. A key can be null, a value can be null. A hash map does not offer a sort method. Here's the syntax for declaring a hash map. Hash map is the class followed by non-primitive data types for the key and the value inside the angle brackets and then the variable name. Since this variable object is created from a class, we use the new keyword followed by HashMap. I would like to point out that the use of a map is very handy in specific situations. You should be aware of the map variable even though in some cases there is a better collection option. Let's go to our basics project in IntelliJ, close any open class tabs. Let's go to the collections package and create a new class called HashMap Test. Let's make some space. Copy in our first test. Let's import in these objects. This first test will show how to add or put a new entry into the hash map. The .put will be used to add the key and the value. The hash map has a .size method so we can determine the number of entries. Let's set a breakpoint here. Let's run this test in debug mode. Let's expand this variable. You can see that here are the key and the value. Let's expand this. Here's the key, here's the value. Let's stop this test. Let's run it again without the breakpoint. And this test passes. Let's write a test that has many entries. Here we added 1 entry and verified the size is 1. And then we'll add 5 more entries. The hash map grows in size as you add more entries. Let's run this test. And it'll pass. Here is roughly the same test, but in the assert statement we'll check to see if a specific key is contained in the hash map. We'll also discover another key was not found in the hash map. The .contains key method will return true or false if the key is found in the hash map. Let's run this test. And it passes. This test will show how to return a value of an entry for a specific key. The .get will return the value. The parameter holds the key. So we provide CAN as the key. The value Canada should be returned. And if we run this test, it should pass. Good question. Let's see what happens if the key is not found. So here's a test where we'll get the value of a key that is not in the hash map. Actual value holds the result. Notice there is no compiler error. Let's run this test. The test passes with no execution error. So the answer to the question, what happens if the key does not exist? No compiler error, no runtime error, and the result is null. Correct. The key and the value must be a non-primitive, and non-primitives are allowed to be null. Take a look at this new HashMap variable that uses primitive types. Notice that there is a compiler error stating that the key and the value are primitive types. Let's comment this line out. So remember, the key and the value must be non-primitive, and if the key is not found, the value returned is null. This test proves the data type used by the key must be the same for all entries. Here is a compiler error. The hash map is declared with a string key. This key is a number. Let's comment this line out. Let's run the test. And it'll pass. This test proves the data type used by the value must be the same for all entries. Here is a compiler error. The value is a number, and the hash map was expecting a string. Let's comment this line out. We'll run the test. And it passes. Here's a test that proves you can remove an entry from a hash map. The .remove method will remove an entry for a specific key. Let's run this test. And it passes. If you need to change the value of a specific key, there are two ways you can perform this task. In this test, we have several entries in a hash map. You can use the .put method or the .replace method to change an existing value. However, if the key does not exist, the .put method will create the entry. The .replace will not find the existing key and do nothing. On this line, we will try to replace the value for key XYZ. When we run this test, it will pass. Notice we tested to make sure the hash map does not contain the key for XYZ. Indeed, it was not found. Here's a test that proves that you cannot have duplicate keys. Notice how IntelliJ is giving a warning for duplicate keys. Time for a Coach Joe challenge question. What happens if you add an entry to a hash map for an existing key? Correct, there is no error, but the value for that key will be replaced. And if we run this test, it should pass. In this test, we have duplicate values. Duplicate keys are not allowed, but duplicate values are acceptable. Let's run this test. And it passes. The last test proves that the key and the value can be null. Here we have a null key. Here we have a null value. And if we run this test, it passes. Here's a summary of all the test code we wrote for this lesson. Over the last 4 lessons, we covered 4 commonly used collections: the array, array list, hash set, and hash map. There is no guaranteed way to select the correct collection, but there are a few clues that could point you in the right direction. Alright class, Han will help us determine the best collection to use based on 3 easy questions. So, if the collection needs a key-value pair, the only choice available is the hash map. So, if the collection does not allow duplicate elements, the hash set is the only choice of the 3 remaining collections. And finally, if the number of elements can change, the array list is the only choice remaining. If the number of elements will not change, use the array. The information provided in the last 4 lessons should satisfy most of your collection needs. There are other collection types that could be used in specific situations. You may need to do some additional research. You should now have an understanding of the key-value pair and the HashMap collection, including the rules and guidelines. Several tests were written to show the syntax and features along with examples that illustrate many of the rules and guidelines. Finally, you should be aware that the HashMap is one of several collection options and is a popular choice when working with key-value pairs. You should also be able to select a suitable collection based on some key decision factors. Your optional homework assignment is to build a test that creates a hash map of players by jersey number. Add several entries, verify the hash map contains a specific key, verify the value of a specific key. In our next lesson, we'll cover boxing and casting. Remember, future senior developers, make it work, prove it works, then make it better. Ready? Break!